Newton was never able to escape this nightmare until the day he died. And 300 years later, Einstein fell into the very same abyss. Both of them touched the same spine-chilling truth. Newton discovered in horror that the universe could only be sustained by a miracle, and he could only describe it as the sensory perception of God. Einstein's equations, however, pointed to an even more suffocating conclusion. The universe might essentially be a sealed room, and the infinite starry sky we believe in could be nothing more than a massive optical illusion. This structure, which left the greatest human minds feeling powerless, is the most mind-bending concept in modern cosmology, the Poincare dodecahedron. Today, let's talk about what this despair-inducing finite yet unbounded universe actually looks like. Let's start with a thought experiment. You're an astronaut, piloting a faster-than-light spacecraft, flying desperately in one direction, never turning back. Months, years, billions of years pass. Suddenly, you see a blue planet ahead. You think you've discovered a new world, but when you get closer, it's Earth. You've returned to the starting point without ever turning around. Just like flying in a straight line on Earth will eventually bring you back to where you started, because Earth is spherical. Its surface area is finite, yet there is no edge or cliff. This is what finite but unbounded looks like in 2 dimensions, and the universe may be finite but unbounded in 3 dimensions. This brings us to the first core concept we must distinguish. Infinity is not the same as having no boundary. In fact, 2,400 years ago, when Aristotle gazed at the stars, he vaguely sensed a paradox. If the universe were infinite, how could it rotate? The ancient Greek spherical shell model, born of intuition, ruled humanity for 2 millennia. People once believed we lived inside a box until Newton arrived. To calculate gravity, he kicked that box away, forcibly stretching the universe into an infinite stage. But the math began to fall apart. Even Newton himself panicked. If the universe were infinite and static, the gravity of countless stars should have collapsed all matter into a single lump long ago. This was an unsolvable bug. 300 years later, Einstein threw out general relativity. He removed Newton's flat stage and replaced it with a trampoline. He told us, gravity is not a force. It is the curvature of space. This leads to an ultimate question. If space curves too much, could it wrap itself into a loop? To understand this, we must raise the dimensional level and separate 2 concepts, curvature and topology. First, take an orange. Stare at its peel. You can see it's curved. That's curvature, a local perspective. Step back, and you see it's a closed sphere. That's topology, the global perspective. It's like an ant living on a Mobius strip. To the ant, its world is flat. It can walk forever, exploring what seems infinite. But it doesn't know that its world has only one surface. After a full loop, it returns to where it started, even flipped upside down. That ant might be us. That's why in the earlier thought experiment, you flew endlessly through 3-dimensional space, believing infinite deep space lay ahead, when in fact, it didn't. In other words, how do we know we're not living on a higher dimensional Mobius strip or a donut-shaped universe? This is the pit Einstein left us. He told us space can have curvature, but he never told us whether that curvature ultimately closes into a loop. So how do we verify whether we're trapped inside one? We can't jump outside the universe to look, but mathematicians gave us a ruler, the FLWRY equations. Hidden within them is a parameter that decides the universe's fate, omega. It represents the universe's average density. This isn't just physics, it's geometry passing judgment. Come, try an experiment with me. Draw a gigantic triangle in space. If omega equals 1, the density is just right. That's a flat universe, also called Euclidean space.
In such a universe, triangle angles sum up to 180 degrees, and you can fly forever without turning back. If omega is less than 1, there isn't enough matter. The universe is saddle-shaped, a hyperbolic space. Triangle angles sum up to less than 180 degrees. It's infinite, and its fate is the big freeze. But if omega is greater than 1, even by a tiny amount, there's too much matter. Gravity bends space, and the universe becomes spherical. Like drawing a triangle from the South Pole to the North Pole, the angles add up to more than 180 degrees. This means the universe is closed. To measure omega, from WMAP to the Planck satellite, we've stared at the universe's baby picture, the cosmic microwave background, for decades. The result is omega equals 1.002. Though the error margin is tiny, the data doesn't lock firmly onto 1. Instead, it ambiguously leans above it. That faint deviation sent chills through scientists. Our universe is very likely closed. If omega is only a hint, the next discovery was solid evidence. French astrophysicist Jean-Pierre Luminet found a shocking anomaly while analyzing that baby picture of the universe. The cosmic microwave background, the remnants from 380,000 years after the Big Bang, is the universe's fingerprint. It contains colored patches, representing temperature fluctuations like sound waves of the universe. In theory, an infinite universe should host all wavelengths, from high notes to low notes. But Luminet's team found a massive bug. The longest wavelengths, those spanning over 60 degrees of the sky, were missing. It's like listening to a symphony where violins and violas play, but when the bass drum and double bass should enter, there's silence. What does this mean? Sing in a cathedral and sound resonates deeply. Sing in a tiny bathhouse. The bass disappears. The space is too small to hold long waves. This directly suggests the universe's actual volume may be smaller than the observable universe itself. To explain this, Luminet proposed a model that shook astronomy, the Poincare dodecahedral space. Don't let the name scare you. Imagine a soccer ball with 12 pentagonal faces, but it's not just a ball, it's a multi-connected space. Like the Pac-Man game, exit the screen on the right and you reappear on the left. In this Poincare dodecahedral universe, if your spacecraft passes through one pentagonal face, you won't hit a wall, nor feel anything at all. You instantly emerge from the opposite face, but with one crucial detail: you're rotated by 36 degrees. That's the magic of topology. It's a finite space, possibly only 80% of the volume of what we observe, yet it has no boundaries. You can never touch an edge. Like a hamster in a cage, running endlessly inside a room with only 12 walls, experiencing an illusion of infinity. Light loops again and again inside this closed dodecahedron. Each boundary crossing is like passing through a mirror. That means the galaxy you see billions of light years away might be the Milky Way itself, its ghost from billions of years ago, a photo of its youth. The star-filled sky might be just a handful of galaxies endlessly replicated as holographic projections in a hall of mirrors. Scientists are now desperately searching for evidence, something called matched circles. If the universe folds onto itself, we should see identical microwave patterns in opposite directions of the sky. The signal is currently buried in noise, but the future Lightbird satellite, measuring cosmic polarization, might finally capture this fingerprint. Hearing this, you may feel despair. Our proud quest for endless exploration might just be running in circles inside a 12-faced box. Maybe infinity was just a joke played on us by light. But from another angle, as Poincare said, geometric axioms are not truths, but conventions. If the universe is truly finite, then we live inside. A structure exquisitely designed, cut with diamond-like perfection. Isn't that more romantic than a cold, empty universe that endlessly dilutes into silence? As French physicist Etienne Klein said, the universe is not only stranger than we imagine, it is stranger than we can imagine. Now, the question is yours. Do you think the universe is infinite or a looping topological magic trick? Leave your prediction in the comments. In 12 trillion years, we'll see if you were right. I'm Lao Ma. Next time you look up at the stars, don't just make a wish. Watch the flickering starlight closely. It might be the gaze you cast billions of years ago after completing a full loop, returning to your eyes. See you next time.